Hello students. Now let us start with a very important topic which is called the Fourier series. Now what exactly is a Fourier series and why I need it? See, usually in mathematics you have seen we expand the function fx in a form of a series. Like you might have studied Taylor series, Maclaurin series, all those things you have done earlier, right? Now sometimes we prefer to express our series in terms of sine and cos, which are very well known periodic function. So Fourier series is that concept which helped me to convert a function in a series of sine and cos, which are the periodic functions. Right. So the standard format of Fourier series is f of x0. One second. So what is the formula for Fourier series? F of x is equal to a0 by 2, which is called the constant term, plus summation an cos nx plus summation bn sin nx. Okay, where n is from 1 to infinity, n is from 1 to infinity. Okay, now this a0, an and bn, they are the constant which I can derive by using the formula. For example, a0 can be obtained by using the formula 1 upon pi integral c to c plus 2 pi f of x dx, right? An is equal to 1 by pi integral c to c plus 2 pi fx cos nx dx. Bn is equal to 1 upon pi integral c to c plus 2 pi f of x cos sin nx dx. These three are called the Euler's formula. Okay, so in Fourier series, basically they will give me a question and I have to expand them in this series, and where a0, an and bn can be evaluated like this. Right, now I will have different varieties. Usually when you write a Fourier series, the period size is always 2 pi. Correct. Now there are two categories we will be studying. One is the interval which is in terms of pi, and the other is an interval which will be in terms of some constant which we called as arbitrary period. Okay. So now since the way I am writing c to c plus 2 pi. Here in arbitrary period I will write c to c plus 2l. Now if c value is equal to 0, then this becomes 0 to 2 pi. Here if c value is 0, then it becomes 0 to 2l. So the first category which I will be discussing will be the limits from 0 to 2 pi. Then if I put c is equal to minus pi, so this becomes minus pi to pi. Right, and here it becomes minus L to L. This is the arbitrary period and this is the period of pi. So first category, what I will be doing, I will be discussing the question of this category. Then I will be discussing the question of this category. Then I will be discussing the questions of this category, and then I will discuss the questions of this category. After that, there is another concept called half range series that I will do, and harmonic, which is the easiest topic of this module, and it is a topic which is always asked in exam. So if you want to score good and if you are too scared of integration, harmonic should be the first topic you should attempt in this module. Okay, so now before starting this, see, when I talk about a series, we definitely talk whether it will converge or diverge. Though in questions you don't have to bother about it, but then also you should know that if I am writing a Fourier series, then it will converge only if it satisfy a condition which is known as Dirichlet's conditions, right? So what is this Dirichlet's condition? It won't trouble you during the questions, but then also you should be little bit aware of it. First of all, the fx should be a single valued. Okay, it is single valued and it is finite. It should be a finite function in the given range. Then period should be 2 pi, which I told you already. Then if it is a discontinuous function, if it is discontinuous in the given range, then the number of discontinuities should be countable. we should have finite number of discontinuity. Even if there are maxima and minima, it should be finite number. So this is the Dirichlet's condition, which tells whether which is compulsory to have, but we don't have to check while doing the questions. Okay. Now sometime what they will ask to deduce the series. So when they ask to deduce the series, we should know a very important result, that if fx is discontinuous, okay, if fx is discontinuous at x, then it converges to, okay, then it converges to 1 by 2 f of x plus, which is the right hand limit, and f of x minus, which is the left hand limit, right? And at end points it converges to 1 by 2 f of c plus f of c plus 2 pi. When it will be used, I will tell you. Right now just keep in mind that there is something like this. Now let us do some homework to start with the questions. Questions will be lengthy, but they are same type of integrals, so you don't have to worry about it. There will be no complicated integrals, simple integrals. Okay. Now what is the requirement? What I should know, what should be the basic knowledge I should have? Few formulas. What are those formulas? Let us list out, so that when we are doing the question, we should not get stuck because of the formula. The very first formula you should know is integral e to the power ax cos bx dx is equal to e to the power ax upon a square plus b square, a cos bx plus b sin bx. Okay. Second formula, integral e to the power ax sin bx, this you have done in 12th grade, is equal to e to the power ax upon a square plus b square, a sin bx minus b cos bx. Correct? Now third formula, this also you have done. I am just writing for your reference so that you don't have to search the books for the formulas. Sin a plus b plus sin a minus b. Then fourth formula, sin a sin b. This is equal to 1 by 2 cos of a minus b minus cos of a plus b. In few questions we need these formulas. Okay. Then cos a cos b is equal to 1 by 2 cos of a plus b plus cos of a minus b. Apart from this, there are questions where I need sine hyperbolic x, which is e to the power x minus e to the power minus x upon 2, and cos hyperbolic x is e to the power x plus e to the power minus x upon 2, which you already know. Now, the very important thing. Usually students are confused in this. Tell me one thing. What is sine 0? Sine 0 is always 0. What is sine pi? Sine pi is always 0. Even if I multiply this pi by some n, this will remain 0. Okay. So now this sine n pi will be always 0. This you have to keep in mind, because while putting the limits of integration, this will come n number of time. Whether I put here 5, 6, 7, 8, it will remain 0. But in case of cos, what happen? Cos of pi is equal to minus 1. Though cos of 2 pi is equal to plus 1. Then cos of 3 pi is equal to minus 1. Cos of 4 pi is equal to plus 1. What you are understanding by this? It means that if I talk about cos n pi, it is equal to minus 1 to the power n. Because see, odd number is giving minus sign, even number is giving plus sign. So I can standardize it, generalize it ki cos n pi is equal to minus 1 to the power n. So whenever n is odd, I will get minus. Whenever n is even, I will get plus. So this will be used in almost every question. Same way if I write cos 2n plus 1 pi. So definitely it is an odd number. So it will give me minus 1. If I write cos 2n pi, means it is 100% sure even number. So it will give me plus 1 always. So this is the common thing which I will be using in question. This will be there in almost every question. These three will be there in almost every question. So with this basic knowledge, when you start the question, it will become easy for you. Right? Now see, I gave you the formula. I gave you the formula. Apart from this, I will be using for integration Bernoulli's rule. So if you have seen my old videos of integration, I have told you the shortcut of Bernoulli's rule. Basically, Bernoulli's is a shortcut of by parts integral. And I have given you in integration portion how to integrate by parts directly by vertical columns. Okay, so that is basically Bernoulli's rule in vertical form. So what is the formula? Integral uv dx is equal to u integral v, then u dash double integral v dx, then plus u double dash and triple integration of v dx. Like that it will keep on going. Right. Now, before starting the questions, it is very important to understand one concept, which is the concept of even function and odd functions. Since in my first video I am discussing the interval 0 to 2 pi, I'll tell you how to check that function is continuous, even or odd when I talk about interval 0 to 2 pi. Okay, so now let us understand that concept and start doing the questions. So let me first start that. Okay, I need some space to do that. Just give me 1 second. I'll add up one page. Okay, so now let's I have added one page so that I can explain you properly. See now, here first of all, what is a concept when I am talking interval matters? Okay, if I am talking 0 to 2 pi, when I am talking about 0 to 2 pi, and if you have any function and you want to check whether it is an even function or an odd function, what you are supposed to do, you find out f of 2 pi minus x. Now, if f of 2 pi minus x is equal to f of x, the function is even function. Okay, if f of 2 pi minus x is equal to minus of fx, then the function is odd. Correct. Now, why I need this, that also I'll tell you. There is a very important property of integration. If you integrate from 0 to pi fx dx, okay, now this integral is equal to 2 0 to pi fx dx if function is even, and this integral is 0 if function is odd. So this helped me to reduce the integration. Okay, so my efforts will be reduced a lot. Now how it will be reduced, I'll explain you. See, what is the Fourier series? F of x is equal to a0 by 2 plus summation an cos nx plus summation bn sin nx. Okay, just observe this very carefully. If you understand, all question will become very easy for you. Now, what is a function a0? What is the value of a0? a0 is equal to 1 upon pi integral 0 to 2 pi f of x dx. Correct? When I am talking about 0 to 2 pi, c value is 0. So, the limit becomes 0 to 2 pi. Now, tell me if the function is, okay, I'll just write down the values first. an is equal to 1 upon pi integral 0 to 2 pi f of x cos nx dx. And bn is equal to 1 by pi integral 0 to 2 pi f of x sin nx dx. Okay, now understand very carefully. If my fx is odd, okay, if fx is odd, suppose, first whenever I will give you the question, you will check like this. Now if fx is odd, what will happen? This a0 value will become, what will happen to a0? 1 by pi will remain 1 by pi. And I told you, if the function is odd, this integrals become 0 directly, right? So my a0 value will become 0. Correct? Now look at an value. Now if this is odd, cos nx we know is an even function always. So odd and even function makes an odd function. So your an will also become 0. And when fx is odd, your bn value, see, this is odd, this is odd. Odd and odd, even. 3 plus 3 is 6 now. So odd and odd is even. So it becomes 2 by pi integral 0 to pi f of x sin nx dx. So overall my formula of Fourier series will get reduced to, see, a0 became 0, an became 0. So my formula will be only this much. where Bn is this. So it will reduce my effort like anything, right? Now let me talk about when fx is even. Now if fx is even function, so the first a naught value will become 2 by pi integral 0 to pi fx dx. And your an will become, because fx is even, cos nx is also even. So 2 plus 2, 4, even function again I am getting. So 2 by pi integral 0 to pi f of x cos nx dx. Correct? And see, limit is also reduced from 0 to pi. That you have to take care. On the other hand, if fx is even, sin nx is odd. So odd and even odd. So bn will become 0 in this category. So bn is equal to 0. So what is the formula for Fourier series now? F of x is equal to a0 by 2 plus summation an cos nx. So how I have reduced the series? See, if the function is neither odd nor even, or if you can't check, in that case this is a formula of fx and you have to calculate a0, an and bn and substitute here. That will give you the answer. But if you know that the function is odd or even, your formulas are reduced. So your efforts are reduced. Okay. Now one more thing here you need to understand. Suppose I have a discontinuous function. F of x is equal to, suppose, phi of x for x is from 0 to pi. Okay. And psi of x for x is equal to pi to 2 pi. So in this case, how you will check even and odd? If phi of 2 pi minus x is equal to psi x, then it is even. And if phi of 2 pi minus x is equal to minus psi x, then it is odd. And once I know that function is even and odd, my concept will remain same. Okay. So now let's move to the questions. I hope you understood the basic formulas. So now let us start with the function questions. Okay, look at the first question now. Obtain the Fourier series of the function fx is equal to pi minus x upon 2 from 0 to 2 pi. Okay, now very first step in every question you need to check whether it is even or odd. And since the range is 0 to 2 pi, so I will check by putting x is equal to 2 pi minus x. Okay, so my f of x is equal to pi minus x upon 2. So let's check what is f of 2 pi minus x. So I will put pi minus 2 pi minus x upon 2. So how much it is? F of 2 pi minus x is equal to pi minus 2 pi is what? Minus pi plus x upon 2, which is equal to x minus pi or minus pi minus x upon 2. So what is this? This is the minus of fx. So when I started with f of 2 pi minus x, I got minus fx. So this is a odd function. Okay. So implies fx is odd. The moment you write that fx is odd, a0 is 0, an is equal to 0, and what is the formula for bn? Bn is equal to 2 by pi integral 0 to pi f of x sin nx dx. Okay, so now let us work on this question. So now I will evaluate the value of bn. So bn is equal to 2 by pi integral 0 to pi, fx means question. So pi minus x upon 2 sin nx dx. Correct? Now let me integrate it. Now if you want by parts, you use by parts. If you want Bernoullis, you use Bernoullis. I always use the vertical column method of Bernoullis, which says that write one here and write another here. If you want to learn the method, you can see my integration concept videos. Okay. And here also I am teaching you. So now this first column I should differentiate till I get 0. So what is the differentiation of pi? 0. What is the differentiation of x? 1. So I got minus 1 by 2. What is the differentiation of 1 by 2? 0. So I'll stop the moment I get 0. What is the integration of sin nx? Minus cos nx by n. What is the integration of this? cos nx by 2. So it will be minus sin nx by n square. Correct? Now make this cross lines plus and minus. So my bn is equal to 2 by pi, and integral I'll write like this. See, first arrow says pi minus x upon 2, one negative sign, cos nx by n. Okay, then second one is saying, see, minus minus minus, 1 minus 2 minus 3 minus, so overall minus. So minus sin nx by 2n square. So this is the integral for this. Right? Now what is the limit? 0 to pi. Now always remember, when you see this and you have to put the limit, sin nx is something which becomes 0 when I put pi or 0. So definitely don't talk about or don't consider this term, because definitely it will become 0. So you have to focus only on the cos term. So now this is equal to 2 by pi. Okay, apply the limit if you put pi. Okay, if you put pi, so here when you put pi, pi minus pi is 0. So this will become 0. Now minus lower limit is 0. So now I'll put 0, but this minus and this minus will become this minus, and this minus will become plus. Now when I'm putting, I'm getting pi by 2 cos 0 by n. What is cos 0? Cos 0 is 1. So 2n I got. Right? So now pi and pi cancel, 2 and 2 cancel. So I got only 1 by n, which is my value of bn. Okay. Okay. So now what will be the solution? I know that my fx in this case is summation bn sin nx, n from 1 to infinity. Correct? So my answer will become summation n is equal to 1 to infinity 1 by n sin nx. Correct? Because bn value is 1 by n. So this is my answer. Now the question has the another part where you have to deduce this series. Now how to deduce this series? Now let us work for the deduction of this series. So for this, I know that fx is this. Usually, what is the range given 0 to 2 pi? So I can take any value of x in this range. So we usually prefer 0 and 2 pi, that is the border values. But I know that sin x is sitting here. So at 0 and 2 pi, it will become 0. So it is of no use to use it, right? So I have to use some intermediate value. Again, if I use pi, it will become 0. So the pi by 2 is the only option. So what I will do, I will take the value of function at x is equal to pi by 2. Okay. So this side I will have summation n is equal to 1 to infinity 1 by n sine of n pi by 2. Correct? Now, what is your question? What is the fx? Fx is equal to pi minus x upon 2. So here if I put pi minus pi by 2 upon 2, what I'll get? Pi by 2 by 2, that is pi by 4. So pi by 4 is equal to, now I'll open the summation. If I put n is equal to 1, what I'll get? Sine pi by 2 plus, when I put n is equal to 2, 1 by 2 sine of 2 pi, not 2 pi. 2 and 2 will get cancelled, so pi plus 1 by 3 sine of 3 pi by 2 plus 1 by 4 sine of 2 pi and so on. Now see, I know that sine pi is 0, sine 2 pi is 0. So remaining thing I should write. So pi by 4 is equal to sine pi by 2. Sine pi by 2 is what? Sine pi by 2 is 1. Okay. Then sine 3 pi by 2 is minus 1. So minus 1 by 3 plus 1 by 5. Like this. If you get 2 terms remaining, you can write. So I got this. Right? So I hope you understood the concept. In my next video, I will do few more practice question. And after that, in next video, I will explain you minus pi to pi. I hope you like the video. Thank you.